Today we are going to discuss about the topics algorithm, flowchart, basic structure of C program, and related to various types of data types, constants and variables. Lecture level learning outcome. After completion of this lecture, students will be able to illustrate the basic programming steps with the help of flowchart and algorithm. Algorithm, it is a finite set of precise instructions for performing a computation or for solving a problem. It helps to write a sequence of instructions which are the raw instructions which can be converted to a programming language. And a programming is a type of algorithm, and all the programs whatever we write are based upon the algorithms. It is like a, example, like you give directions uh, to indicate the address of a house or to locate at which lane the house is. So you give some directions as to where to start, where to stop. So similarly, the algorithm work like, or if you want to compute some mathematical operation like cosine angle of 90 degrees. Um, so we do some calculations before computing this. So similarly here we go through some procedures uh, to before in order to develop the program. And properties of algorithms. Algorithm takes some input and it produces an output. And the what are the steps in acquiring the output? Those are written in a very precise manner. And the algorithm is a valid algorithm if it produces a correct output. When the output is correct, you can say that whatever steps you have written, those are all the correct steps. And it should be finite. There should be a stop point at at the sequence of steps. There is you should not write a steps iteratively, or if there is no stop for a particular procedure, that means the algorithm is not correct. And each step whatever we are writing, so that takes some amount of time. That amount of time also should be assessed. So whenever there is assessment of a particular sequence of steps, you say that whatever algorithm you have written, it is effective algorithm. And whatever algorithm you write, that should be also be applicable to the problems of similar type. So let us see an example. A simple program writing raw steps to print this good morning. So how do we start this? Um, Generally, we write the algorithm with the start instruction and we end the algorithm with the stop instruction. So this is a simple program. What is the task in this example is just to print this particular statement. So the task is printing some statement which is given in the question here. So this is our simple algorithm. The next one, to find area of a triangle. So here we are not printing anything. We have to compute some values. So in general, the start and end of the algorithm should be start and stop. Now for finding the area of a rectangle, so we have L into B. So for calculating this, first of all, we should have the value for length and we should have the value for breadth. So take length and breadth. So we need some input before processing this. So that input we are writing here, take length and breadth and store them as L and B, that is length and breadth. Then multiply L and B and store it in area. Area equal to L and B. So whatever result is calculated, the product of this is stored under area A. And then print area. So the result is with A. So we need to print the variable, or we need to print um, the attribute which is actually containing the output. So here A contains the actual output. So we are printing area. So our task is finished. So we terminate the algorithm using the statement stop. So 5 steps are required here. Then one more algorithm to check whether a person is eligible for vote or not. So eligibility for this is he should be of minimum age 18. Okay. So how do we assess that a person can vote? We have to check the age. Take the age of the person, check whether it is equal to or greater than 18. If it is, we allow the person to vote. If it is not reaching this condition, equal to or 18, we state that the person is not eligible. So let us see the algorithm. So first one is start. Take the age and store it in some variable. So let us take age. I'm storing in this variable. We call this as variables. Like this is similar to your mathematical expressions. If you can see the linear algebra. Uh, See, we write c is equal to x plus y, right? So we call this each one as variables. So similarly here, whenever we are storing any value, we store it in some variables. Then check age value. If it is greater than 18, then go to step 4. Okay, so that means we are suggesting some conditions. If it is greater than 18, that means if the condition is true, then execute the statement which is present in step 4. Else step 5. Else means what? If this condition is false, if this condition is not met, that means the person is below 18. So then go to step 5. So under step 4, what are we writing? Eligible to vote. Okay. So after eligible to vote, then what do? We have to stop this. We need not go to step 5. The condition is false, we go to step 5 and we print not eligible to vote. And last one, stop. So this is these are some sample algorithm students where you can write a series of steps for a particular given problem. So this is just to check a number is positive or negative. So we write in a similar manner. If a number is, take a value and store it in n. If it is greater than 0, okay, then we go to step 5. So under step 5, we can write it as positive number. Okay, so we can write it as print positive number. If it is less than 0, we write step 6 is equal to print a negative number. And then go to step 7. So step 7, what do we do? You can stop. And this is about flowchart. So flowchart helps to represent whatever steps we are writing in algorithm that can be represented in terms of diagrammatic notation. So we shall see what are the diagrams that are useful for this. So here we use arrow line. So this indicates how to connect one symbol with the other. And then terminal. So terminal will indicate the start and stop. So in algorithm, we have start and stop. So here in flowchart, we have start and end. Start of the algorithm and end of the algorithm. Those two statements you can represent using this terminal. And process. So they will change, they represent some set of operations, any execution of any conditions or execution of any expressions that can be done in this particular process figure. And then decision. So decision will, here we try to give some condition. Is age of the person greater than 18 or not? Whether he is eligible to vote or not. So all those conditions can be given use with the help of this particular rhombus symbol or decision box. And then the input and output can be represented using this particular symbol, which is a parallelogram. And the last one is connector. So sometimes the flowchart goes very long and we need to write in multiple pages. Then connectivity from one page to another can be given using this one page connector. And this is a one more connector. So this is when the target is on another page, we can use this one. And this is for labeled connectors. So when you have multiple uh, outputs which are coming across the different uh, modules, you can just connect them through a smart circuit. So advantage of flowcharts, it helps for good communication. You can present the logic very clearly with the help of diagrams. Effective analysis of whether the algorithm is written properly or not. Documentation will be made easy, efficient programming maintenance, and coding of the program will also be made easier with the help of this flowchart. So these are some examples of flowchart. So this is the same symbol we use for start and stop to find the simple interest. So for simple interest, we need to first give some inputs. We know the simple interest formula is PTR by 100. So first of all, we need to give some input values for this PTR. So this symbol is for storing the inputs. And this is for processing the rectangle box. And this is for output. In output, we normally print the result. So for input and output, we use the same symbols. Another example to find the bigger of two numbers. So start and stop. After this, we give some inputs to the two variables A and B. And we have to check that which number is greater. Then that means we have to give some condition. Is A greater than B? If it is yes, print A is big. If it is false, print B is big. Okay, so we have to write yes and no compulsory on these edges of this particular rhombus. Then whichever path is selected based upon the condition, then along that path flowchart reaches to stop. So this is all about the flowchart, students. Next one, we have constants, variables, and data types. So students, in order to start writing the program, we need to understand some basic elements which are required to write the program. Like if you want to write a statement, we need to know what are A to Z, what are the letters we have, what are the grammar rules we have, right? What is a noun, pronoun, right? Without this, you can't write a statement. So similarly, without knowing all these basic things, we can't write any C program. So that's why we are discussing this one. So this is the first one. We have the keywords. So we use some of the words are fixed. We use all these things. These are fixed words which are used by only the C. Uh, that is the processor. Okay, so these are the keywords. And second one, if you want to write some variable names, like we have calculated the simple interest, that is PTR by 100. So if I want to use these variables are called as identifiers. The names which are given to variables or file names or any names, those are called as identifiers. And then if you are using some numbers, all those numbers are called as constants here. And we are also having the concept of strings in the sense, we may also use letters A to Z. So those are called as string letters. So how to use this, how to declare this, we shall see in the next coming classes. Okay, so perhaps we just discuss about the briefly. Okay, we try to understand what is the terminology of each of these. Then we have different operators which can be used for execution of any arithmetic operation. So we have arithmetic operators, that is plus, minus, multiplication, division, and modulus. So modulus is the remainder which we get, that we represented it as module. So here if you see this 2 you get when we use this divided by, and when do we get this, when do we use this percentile? This is for getting the result. This is for identifying the remainder. For remainder to know what is the remainder, we use percentile symbol, which is also called as modulo symbol. And then we have other operators like logical operators. Okay, so various symbols which are on the keyboard we will be using as operators. And then we have white spaces um, to differentiate between the lines and different variables. We use white spaces. And among the various variables which we use, there are three basic variables or data types which you have to use. First one is integers. So integers are the numbers which we use. Okay, uh, and this can be of signed or unsigned. Like if I give a equal to 5 or b equal to 15. So these are all integers. Integers are the numbers where there is no decimal. So this is purely integer numbers. And it takes 8 bits. Uh, it is represented by 8-bit digit. Okay, it is represented by 8 bits, and integer takes a memory of 2 bytes. Now, what is this byte again? So we have seen in the previous session that 8 bits can be considered as one word. Okay, so a word is stored in terms of 8 bits, and this 8 bits put together is one word or one byte. We can call it as one byte or one word. So 1 byte of memory. Okay, that means 8 bits of memory. And integer will take, whenever you give some integer value to a variable a equal to 5, this to store this 5 under a, it takes 2 bytes. Okay. So that is 2 into 8 is 16 bits are taken. And here you can declare positive integers and negative integers, which are called as signed or unsigned. Unsigned means is positive integer, signed indicates a negative integer. And it has some limitations so as to uh, related to the range of these numbers, how many numbers you can give under the integer. So that is the largest positive integer is 2 power 7 minus 1, 127 is a range for this. And when compared to the negative numbers are stored in the form of complements, 1's complement and 2's complement. So integer numbers are again characterized as characters, short int, long int. So all these are integer numbers only, but memory size is differing. Short integer will take 1 byte, int will take 2 bytes, and this will take 4 bytes. Okay. And characters are will also take 1 byte. And coming to the floating point numbers, floating indicates all the decimal numbers. So instead of 5 here, I have to give 5.4. The decimal numbers are called as floating numbers or real numbers. And if you want to allocate, and this will take 4 bytes of memory. If you want to allocate more amount of memory, if you want to increase the range of this, we can also go for double. We can declare a variable as double, which indicates it is also float number, but it will be allocated with a more amount of memory. It will take 8 bytes of memory to store the value. And we have the constants. We have seen here, so characters are there. Characters in the sense some you are instead of numbers you are storing some letters for a particular variable. So this is called as character. It will take 1 byte. So here similarly we have these numerical constants. So these are the different declarations we can use for long int, unsigned int, long int, unsigned long int. So this is purely for simple integers. Constants indicates that uh, when you declare them, the values of that particular variables are not going to change. So this is strings. These are all string literals or string constants. That means once you have assigned, these are not going to change. You can also, and each and every, if you declare a equal to double x, that means a is taking a value of x here. Whenever you write something in between the double quotes, it means it is a string. If you write in terms of single quote, it means it is a character. And so in the memory, a will be stored, and what is the value of a? Value of a is x, so it will be stored in this manner. And an equivalent value for x will be there, that is a machine level code will be there, which is called as ASCII value for x. So x will be having some meaning with respect to the processor. It will store x as uh, related to some number, that which is called as ASCII code. From A to Z, each and every letter will be understood by the computer by converting the letter into some number, which is called as ASCII value. So it can also store a equal to x as a equal to the equivalent ASCII value of this. It is just an example. And these are some of the rules for declaring a variable. Variables are all case sensitive, and the length of the variable can be 32 characters. And case sensitive here indicates that small a is considered separately and capital A is considered separately. Both are not same letters to the computer. Okay, uppercase and lowercase are different. So here, this small a is one element to the computer and capital A is another element. It together it takes it as two separate elements. And these are some examples of declaring a variable. Okay, sum is declared with some value. I want to store 0 is simple integer, so we have to declare it as int sum equal to 0. And similarly, if I want to store a variable with some decimal number, I can declare it as float x equal to 5.6 or some explanation number. Or instead of this, if I want to declare some alphabets, then I can use char some variable equal to, within single quotes we can give any type of symbol. So let us review the salient features of this lecture, students. Algorithm is a finite set of precise instructions for performing a computation or for solving a problem. And flowchart is used for representing algorithm in pictorial form. And we have discussed about tokens in C and the literal strings. And these are the various operators we have seen. And white spaces, we indicate the white spaces using backslash, star mark, then again space, backslash, or star mark and followed by backslash. So this indicates commenting lines or white spaces. So they are neglected by the compiler, white spaces or commenting lines. So let us see a few questions. A step-by-step method for solving a problem using English language is called as among these four, what can be the answer, students? Just take a few seconds and identify the answer. So answer is algorithm. One more question. The graphical representation of algorithm is called as. Try to identify the answer. Answer is flowchart. Yeah, if you have one more question. What are the entities whose values can't be changed? In the sense, if you are given some value to a particular variable, throughout the program, value will be as it is. You can't change the value in between the program. So those variables are called as uh, which one? Constants, variables, modules, or tokens. Yeah. Let us see the answer. Whose values can be changed? So the answer is variables, and whose values can't be changed? Those are constants. So whatever answers, if you have given, whether it is correct, then go to the next slide. Otherwise, review the video once again. So lecture outcome, students. Having completed the discussion on algorithm, flowchart, constants and variables, you will be able to write an algorithm for a given problem and design a flowchart for a given problem. And these are some of the lecture level questions. Write an algorithm to find the area of a triangle and also to find whether a given number is odd or even.